Good day all.
Yeah, we'll be continuing our video, our series on universal gates. Now, the last time we treated NOR gates, and we used it to implement every other logic gate, about 6 of them, the 6 other ones. Now, we are going to be using the NAND to do the same thing in this video. Okay, let's start. Our NAND, you know that this symbol is this. This is for 2 inputs NAND. We have A dot B or bar. This is what our output is meant to look like. A dot B what or bar. Now we have achieved this now. So we are going to be making the diagram of the other ones, using the NAND to implement every other logic gate. Okay, so let's start with NOT. Our NOT symbol will be this. You have your one input, then you split the input into 2 to go into the 2 input of your your NAND. So at this place we'll be having what? A bar. So at this point it is split into 2. A went here and that A went here. Then at the end of the whole this thing, we're going to have A dot A or bar. This is also equivalent using the Morgans, splitting the sign on top. You have A bar plus what? A bar. And we know when we are adding like terms, we just take one. Hence this. So as for your words, your knots. Now moving over to your OR, which we know the expression is what? A plus what? B. This is what we want to start our output. So we'll bring this expression out, A plus B. And like we said in the other video, after writing the expression, you double bar it. We are double barring it now this time around because we are having only one sign here. In cases of XOR and XNOR that are SOP functions, we have to double bar the thing about 3 times because we are having 3 signs there. When I say sign, I mean addition and multiplication. So since we are having only just one sign here, we'll just double bar it once. Now, this is still equivalent to this. Nothing has changed. It's still the same expression, but we want to achieve something with this. Now, using the Morgans, you can actually split this, and it will give you what? A dot B bar bar or bar. The one I splitted is this last bar is what I splitted. So that last bar that I splitted, change this sign to what? Multiplication. So we have a negative a bar, which is a complement of B, and then a NAND function. The NAND function, what you have to see for you to know something is NAND, you have to see the multiplication and then the bar on top. So this is a multiplication and this is a general bar on top. So this is a NAND. Why this is just negation or not. So we can draw this now. We have A and what? B. We negate our A or complement our A. The same thing with our B, we complement it too. So we'll be having the output to be what? B bar. And over here, A bar. Then finally, you join them with another what? NAND. Which is what? A bar dot B bar or bar. Or bar. Now this is still equivalent to what? To this. If you are to split this, the general bar, this one that is joining the two of them, you have A double bar plus B double bar. This, like we said earlier, when you see double bar, it's still equivalent. So this is still what? Your A plus what? B. So we have achieved this using only what? NAND. The same thing goes also for your what? Your AND. The same principle applies. Your function is what? A dot what? B. you bring out the function out, you have a dot b, then you double bar it. We have a multiplication sign and a general bar. Multiplication sign and a general bar. So this alone has given us our what? NAND. Then we will negate the final answer. Doing that, you're going to be having a b. We join the two of them together. It's a straight line, not a curve. Okay. Then we have what? A dot b all bar. We have achieved the brackets. Now we have to negate it again. Yeah. When we negate it, this is what we also have as output. We have this is it here. Then negating it, this is what we also have as output. This is 2 equivalent to what? A dot what? B. Okay. Okay. Let's try for our no. For our no. So we write that expression again. A plus B all bar. Then we double bar it. We change this plus to what? Multiplication using the Morgans. Then the third bar will be splitted. We have double bar and we are having what? A bar dot B bar. This is a NAND. Then this one, and this one is just what? We negating it. So coming over here, we have A, we negate A, and we also negate B. Okay, now we are having B bar, A bar. Okay, now from here, we have just achieved to bar this and this. Now we have to join the two of them together so we can achieve that in the brackets. So at this point, we'll be having what? A bar times B bar all bar. We have achieved this other one in the brackets. Now finally, we negate it again. To give us A bar B bar, then double what? Bar. Having this. Now, from here, if we actually want to, we're asking ourselves, is this and this the same thing? Let us check. If we remove the two bar on top, we're now left with what? A bar dot what? B bar. Now using De Morgan's rule, if we want to join the two bars on top together, we will then have A plus B all bar. So if you want to separate the bar and join the bar together, you will still have what? The same thing. Now we have done for our what? Our no. Now let's also try for our what? XOR. Still follows the same principle. Now our XOR expression is what? A B bar plus A bar B. That expression, we write it out again. Now this from here, since we're having three signs, this is an SOP. So each of them are going to be what? Double barring it. This double bar is for this multiplication, and that double bar again will be here for this multiplication. Then for this sum that is joining the two products, we have a bigger what? Double bar. Now double bar of the same length are what cancel out. For instance, you can't cancel out this and this. They have to be of the same length for you to cancel out. Now, okay. Now looking at this, this is a NAND. This is a NAND. So we're good with this one. So also is this one. This is also a NAND. But the issue now is not this plus. This plus here will not allow us to get a NAND. So we're going to be changing this plus. When we change that, we'll be having then one of these bar will split, the other one will also split. Then we have three bars now on top. Then A dot B bar and what dot A bar dot B. Right now, from here, these two can cancel out. These two can cancel out, and we would still be having what? A general double bar, and is now joining A so this is what we have achieved now. We have a NAND. So what we're going to be doing here, we negate our B and we'll join it together with NAND and then the same thing, then finalize the whole thing with a NAND. Now someone will ask me, why do we cancel out this double bar? Yeah, we cancel it out because first of all, they are of the same length and they will have no, it will cancel itself at the end of the whole day. So at this point, we had a NAND already. A NAND already. The same thing at this point, we also have a NAND. For just this first bar, this last bar, we have a NAND already. Now, this other two bar will imply what? Us negating it. And that bar on top, we also say we should also negate it again. So it's just common sense that you just cancel out those two on top of the same length. Now, this is what we're going to be drawing now. Now we're going to be having what? A, B, A, B. For this first one, we'll be having just A. This one we are having A bar. Then we join the two of them together with a NAND to what? Achieve A dot B bar or bar. We have achieved this one in the brackets. Now going over to this other one here, we have to be negating our A. But our B will still remain what? The same. Then you join the two of them together with a NAND. So we have our output here to be what? A bar dot B or what? Bar. We have achieved this and this, the two of them, and this bracket, we have achieved them. Now finally, it's now for us to now what? Negate, to just we'll find in general NAND. This other NAND in the center. What we are going to be doing now. So we'll be having what? A dot B bar or bar in brackets times A bar B or bar, then or bar. We have what? Achieve what? X or. Now is this and this the same thing? Yes, they are. When you split this one, this bigger one, you will still have double bar A dot B bar. Then our sign will then change. Then double bar A bar B. These two cancels out. And we're left with what? With this. So that's for our what? Our XOR. And we have seen that is actually what? Correct. Now let's do for our XNOR. Now for our XNOR, we know that the expression is what? AB plus A bar B what? Bar. This expression, we'll write it down again. A B plus A bar B bar. Now we are having three signs, so we are going to be what? Applying three double bars. Now, our aim now is to change this plus to what? Multiplication. So we'll be splitting this one into two. And we have the first bar intact, but the second one we are splitting it. And we still have about three bars and A, B. Then our sign will then change to what? Multiplication. Then A bar, B bar, then three bars on top. These two will go off. Then we are left with what? We're just left with what? Just one A B dot. Okay. So this is what we are going to be using to make our words, our diagram. This. Now we have our A and our B. Our A and our what? B. We join the two of them together. Over here, we're going to be negating this. The same thing here, we negate these two. So we have negated, from here we have what? A dot B bar, which is just this. The other one, we have just done what? A bar and what? B bar. Now we need to also join the two of them together. So we can have what? A bar dot B bar all bar. Getting this other one. Then finally, we join the two of them with a general word, NAND. Then you have A B bar dot A bar B bar all bar. This, and then finally this. Getting these words back. We have gotten this. Now, is this and this the same thing? One more proof before we go. Yes, they are. Now, splitting this last one, this first bar, this one, splitting it, we have double bar A B. Then our sign will then change. The next one, double bar A bar B bar. This goes off, and we're still left with what? With this. Okay, so that's all for this video. Subscribe if you haven't, like, comment, and keep being the best version of yourself. See you guys in the next video. Goodbye.